Welcome back, Marauders. This video 2.3, modern view of the atomic structure. We're going to talk about subatomic particles and how to figure out how many there are in an atom or an ion. So in the modern view of the atomic structure, atoms are made up of three subatomic particles. We have protons and neutrons, which exist in the nucleus. So that's the dense center of the atom. And then on the outside, in the electron cloud outside the nucleus, we have the electrons. And we'll talk a lot more later about how the electrons are arranged, but right now what we want to know is that protons and neutrons are in the nucleus. That's where most of the mass is. It's a really dense center, and the electrons exist outside. Protons, as the name implies, have a positive 1 charge, and they have a mass of about 1 atomic mass unit. You don't need to know the exact mass, just know that it's about 1 ANU. Neutrons have a neutral charge, so they're neither positive nor negative. They also have a mass that's about the same as a proton, so about 1 atomic mass unit for a neutron as well. They have essentially the same mass. And then electrons exist outside the nucleus. Electrons have a negative 1 charge, so the opposite of a proton. And they have a mass that is much, much smaller than the mass of a proton or a neutron. They have some mass, they are matter, but usually we assume that they have almost no mass. We don't really include that in the mass when we're figuring out mass numbers. All right, so when you see the symbol for an atom, it might look something like this. Here's the symbol. It's going to be either 1 or 2 letters. If it's 2 letters, the first will be capitalized, the second will be lowercase. In this case, it's C for carbon, which is just a single letter. Up here at the top, you'll have a mass number. So the number at the top is always the mass number. And then if there's another number down here, it's the atomic number. The atomic number is not always shown because it's kind of unnecessary. We know what the atomic number is based on what the symbol is. Carbon is always going to have an atomic number of 6, so it doesn't always have that written down in the symbol. All right, so figuring out the subatomic particles, protons, neutrons, and electrons. Protons are going to be equal to the atomic number. So since this is carbon, it has an atomic number of 6, then this would have 6 protons. Neutrons is going to be the mass number minus the number of protons. So we have a mass number of 12 in this case, minus, we had 6 protons, so we have, in this case, 6 neutrons as well. They're not always equal. In this case, they happen to be. And then electrons are going to be equal to the number of protons in a neutral atom. And then in a few minutes, we'll see ions that have a charge, and you'll subtract the charge if it does have one. But in this case, it's just electrons equal to protons because it's a neutral atom without a charge, so we have 6 electrons as well. So protons and electrons will be equal in a neutral atom. Isotopes. So isotopes are atoms with the same atomic number but different mass numbers. Okay. Why do they have different mass numbers? Well, they have different mass numbers because they have a different number of neutrons. They have the same number of protons. That's what gives it its identity. So it's the same type of atom, but it has a different number of neutrons, therefore giving it a different mass. So example, carbon-12 and carbon-13, they can be written out like this with the name and then a dash and then the mass number. It could also be written like this, carbon with the 12 out in front, carbon with the 13 out in front. So we're identifying 2 different isotopes, carbon-12 and carbon-13. We already figured this one out. So protons, we know carbon, if we look at the periodic table, its atomic number is 6. That's why it's not always written there. The neutrons, okay, in this case would be 12 minus 6, which is 6. And then the electrons would be equal to the protons because there's not a charge, so they'd also be 6. So just like in the last example. What's the difference between this one and this isotope? So protons here, still 6 because it's still carbon, that hasn't changed. Neutrons is going to be the mass number, which is 13 minus 6. So here's where the difference is, 7 neutrons. Electrons still equal to 6. So the only difference between these 2 isotopes is the number of neutrons. This one has 6, this one has 7. So this one's slightly heavier, but the neutrons don't have a charge and they don't really affect the physical or chemical properties of the atom. So it doesn't make a big difference. Just to know that different ones exist. We'll find out why that's important when we calculate average atomic mass. All right, so a little bit of practice figuring out how many protons, neutrons, and electrons are in these neutral atoms. So protons, right? Protons is just going to be equal to your atomic number. That's written down here at the bottom. So for beryllium, it's 4. If we didn't have the 4 there, we could find that on the periodic table. Neutrons is going to be the mass number, so 9 minus 4, so we have 5 neutrons. And then electrons is going to be equal to the protons. Again, we don't have a charge yet, so we have 4. Over here with the sodium, so sodium has an atomic number of 11. The neutrons are going to be 23, the mass number, minus the number of protons. So 23 minus 11, so we have 12 neutrons. And then the electrons, again, equal to the protons since it's a neutral atom, so it would be 11. All right, protons are not always equal to electrons. When we have ions, which we're going to see a lot this year, ions have gained or lost electrons. Okay, so the protons never change. The protons are going to stay in the nucleus, and they're not gained or lost during chemical reactions. But electrons will be transferred during chemical reactions, so they will be gained and lost, and that's how ions are going to form or are going to achieve charges. All right, so here we have protons, neutrons, and electrons in this example. So this you can tell is an ion because it has a charge. The +2 is telling you the charge of this ion. It's still magnesium with an atomic number of 12. That hasn't changed. So the protons are not gained or lost. That always stays the same. That's just the identity of the element. The neutrons, okay, just like before, 25 minus 12. So we have 13 neutrons in this example. And then electrons. So here's where the charge comes in. So we're going to take the number of protons, which was 12. It would be equal to that if it didn't have a charge. But we do have a charge, so we're going to subtract 2. This one's lost 2 electrons. It has only 10 electrons. All right, so it has 10 electrons, each with a -1 charge. It has 12 protons, each with a +1 charge. And since it has 2 more positive charges than negative charges, that's where it gets the overall charge of +2. Again, the protons are never gained or lost. It's just the electrons that are going to change to give you the charge. Here's a negatively charged ion. So this one is nitrogen. Here I didn't give you the atomic number, so we're going to have to look that one on the periodic table. We'll check out the periodic table. This whole number up here at the top in the box with the nitrogen tells us that its atomic number is 7. You can write that in if you want to. So we're doing protons, neutrons, and electrons for this ion. So protons are 7. Neutrons, 14 minus 7. So 7. And then electrons are going to be the number of protons, which is 7, minus the charge. The charge here is a -3. So minus a -3 gives us 10 electrons. This one's actually gained electrons. And that's how ions achieve a negative charge, is that they have more electrons than the atom they came from. Working backwards for a couple examples here. So this one is writing the symbol for something that has 9 protons, 10 neutrons, and 10 electrons. So look at the protons first. We have 9 protons. That means we have an atomic number of 9. So look at your periodic table. Find the element with an atomic number of 9, which happens to be fluorine. And that tells us that the identity of this element is fluorine. So we draw the capital F. Neutrons 10, so we know the mass number should be 9 plus 10, 19. And then we have 10 electrons, so 10 negative charges, 9 positive charges, so we have an extra negative charge, so we'll put a negative right there. You don't need to put the 1. If there's just a negative sign, the 1 is implied. So when you have a -1 charge, just a negative sign will be adequate. Last one, 24 protons. So we'll look at our periodic table, find atomic number 24. Cr for chromium. So chromium has 24 protons. Okay, doesn't matter how many neutrons, doesn't matter how many electrons, we just look at the number of protons to figure out the identity of the element. So anything with 24 protons is always going to be chromium regardless of how many neutrons or electrons it has. All right, for our mass number, we'll add together the 28 neutrons plus 24 protons. Remember, they each have a mass of about 1 atomic mass unit. The electrons are almost weightless, so we won't really worry about those. And so our mass number is 52. And then our charge, if this is an ion, we have 22 electrons, 24 protons. Okay, so if you have 24 positive charges and only 22 negative charges, then you have 2 extra positive charges. So this has a charge of +2.